How about a note taker for the session itself?
So today is a once in a lifetime opportunity. It's really easy today.
It's the first step. Yeah, okay. Thank you. It's the first step on the pathway to glory. So, thank you. Let's start the sheets. Hello and welcome to the Decentralized Internet Infrastructure Research Group. We are an IETF activity, and as such, the note well might be a little bit different from what you've seen in IETF working groups. We're under a similar but not identical IPR regime. A little sort of coordinates for finding us. We've got, of course, the mailing list. URL is there, and we've got a wiki as well. So today's agenda is going to be the note well, which we just did, minutes and minute taker and JavaScribe. We're much gratitude to the folks who volunteered, blue sheets, and now we are agenda bashing. So we've got 3 talks. Whoops, that's bad editing on my part. We've actually only got 1 talk from Lisa Zhang, which is decentralization from the ground up. The other 2 talks are going to be Leandro's on MeshDApp and Shenyan's on a blockchain-based testbed for PGP verification. Once we're done, we'll talk a little bit about a possible future interim, and then we're going to end a bit early, and Shigea will be leading a side meeting on his topic. So thank you. Any bashing? Okay. Leandro?
Hi, so I'm going to present some work we've been doing in the last year or so, related to like longer work we've been doing with a wireless community network in Barcelona. This is therefore about decentralized networks which emerge because someone needs connectivity and they set up an antenna, they make connections with neighbors, and then all these routers which are connected wirelessly, they form a mesh network, and then that mesh network can provide coverage in a given region. In our case, we are working with one group of the Gifinet community network, which has about 60,000 members in the Spain, mainly in Catalonia and the south of Catalonia and in Valencia. And in Barcelona, there is a community network where the university is part of, which has about 100 routers. And then, of course, in the edges, we have like access points where people connect with end-user devices. And on the other side, there are one or several internet gateways which allow people to reach the internet. So the network is decentralized. Everyone contributes a node. And then we use the term crowdsourcing because it's not just about setting the network, but also about contributing connectivity and about investing in the capacity of the network and so on. So we explored the idea that we would like to have networks which are self-sustaining, not only in terms of traffic of data, but also in the, let's say, traffic of economic value. So people can pay for the infrastructure and the services they provide. So as I said, it's about combining, let's say, routing of data, which is automated. We use mesh networking routing protocols, and in a way, try to find if the economic flow can be also automated and make the network sustainable and self-supporting. This is based, in fact, the idea in a mechanism that Kifinet uses for, they call it economic compensation. So the infrastructure is shared, and then the payment is based on CapEx or OpEx and is proportional to contribution and consumption. So automation is important because, as we have seen in the larger community network, unless we automate, things are very difficult to manage. I mean, dealing with money is complicated. Fair accounting, because there are participants which are very tiny, others which are very big. Finding the optimal fair charging is important. And we have seen, when especially dealing with money, operations have to be, I mean, you need to be accountable with respect to your members, also to the tax office. You need to have a proper accounting. And if there is a commitment, the commitment has to be, we use the term inexorable. So if we commit, things have to happen as planned. And well, the important concepts in this work is the idea of automation first, fairness, of treat everyone correctly, and regarding the accounting, that has to be, we can use the term irrevocable, unalterable, with respect to the past. And with respect to the future, we use the idea of smart contracts to reflect that if there is a commitment, imagine like a service agreement to connect to the internet, or an agreement to route traffic or whatever, once it's signed, it has to happen sooner or later. So it's inevitable or inexorable because it will work as expected. So in the system, we have like this, we could divide it into three layers. One part is the monitoring system, where we have a database of nodes that participate in the network, and we collect measurements about traffic. And in the middle, there is let's say, the network chain from a user that connects with a user device to an access point. Then there are several routers, and in the end, somewhere, there is a gateway to the internet. And all that network is, let's say, supported by a group of servers. Imagine like there are several participants who want to have a copy of the accounting to make sure that things are really not correct and no one is doing anything wrong. You have a few servers where the smart contracts and the blockchain are stored, and so we use a private blockchain, a permission blockchain inside the network. And then the idea, well, the formulation is a bit complicated, but the idea is very simple. I mean, people get to access points, they find prices for like the network access. Imagine like paying for electricity, you see how much is kilowatt per hour at that moment, and the price is collected from users. There is a smart contract that gives you, I don't know, a few gigabytes of traffic, and then you deposit an amount of money, and if the service is correct, that amount is then taken from the user, and those payments from end users go to we call it the wholesale market, where we collect data about who contributed to deliver that traffic to the clients, and then the amounts of money are split proportionally to the effort done by the routers and the gateways to the internet, because are the ones who, similar to the power generation, you have different sources of electricity. The price per kilowatt hour is a balance between demand and offer. And then there's a mediator who is the smart guy who computes the kilowatt per hour price for the next time, depending on how much each router charges or each gateway charges to move through the network. So we have a group of smart contracts. We have the mesh network, the DAO, and then on one side we have, on the right side, we have an oracle, which is the one that collects monitoring information. Imagine like in a trustable way. So they measure traffic in different points of the network to avoid that people can tamper with the traffic. There is also a local currency, a local token, which is supported by an ERC20 contract. And then on the side of consumption, people can select and instantiate one of the smart contracts that rule like access, like what you would do if you wanted to connect to a mobile operator. You would choose the one that, per volume, per time, per whatever, per quality. And on the right side, routers, we have a smart contract that is on ERC 721 compatible, which deals with the, let's say, tokens that reflect ownership of devices. So you own a device, you have a token, a non-fungible token that reflects that you own that device. And then, of course, when that device works and does forwarding, it gets paid. So we pay the router gives the money to the owner. So this is the list of contracts and the ingredients. So basically, yeah, we need a fungible token to pay between all participants in the network. We have a non-fungible token that allows to manage ownership of the devices in the network. We need this oracle, which allows to connect the economic and the technical worlds to make sure that traffic is properly accounted. And and the contracts that I mentioned about the three roles in the system. This is implemented using the Geth Ethereum software, but configured to work in a proof of authority mode. That means we have an intranet, let's say, where we use our own servers, but then that allows us to write the smart contracts in Solidity, and the environment is quite stable. So we also tried Hyperledger Fabric, and so we took this because simply it works. And then, of course, in the network, our network is already there, but imagine someone wants to set up a network in a different location. They would bootstrap the network by adding at least one server. Then the network can grow by minting. We call it minting devices, registering devices in that local blockchain. Sooner or later, internet gateway will appear. It is necessary to get to the internet. Sooner or later, an access point will appear, which is required to connect end users. With a mesh network, then people can select a contract and start a connection, and then the system periodically would compensate everyone. So owners of devices would be paid for the effort the device does, and eventually, over time, that owner would be compensated and would see its investment returned, and maybe with some profit if necessary, although in our network, social profit is more important than economic. This is a kind of log of activity in the prototype. You can see that, well, in the servers, you see load when the network is bootstrapped, when we add a node, when we establish a contract, and when the compensation is run. But we don't do it every second. We do it periodically. It could even be every day, not necessarily to make it too fast. And then this is a picture that shows how money flows. You can see that clients have less and less money, the red line, in exchange of the blue line, which means that the client is getting more and more traffic. So you pay for the traffic you get. And then, of course, the routers, which are involved, and the gateway gets money out of that. And because there is some imbalance, like in the electric system, sometimes every period the prices are not properly fixed. So there's a reserve account where we save money to compensate in every cycle whatever small differences between prices and costs. So we experimented a bit. We learned a bit from the implementation, and we started to prepare a pilot with the local network and see how they perceive the system, because we want to later on scale it up to a wider Ethernet network. And but I think it's not worth to enter into the details if you are interested in any aspect that I can comment. But basically, I think we achieved the aim of combining routing that we've worked on the topic for a few years with also routing of economic flows to make networks self-sustaining economically. And with the community, we have discussed that, well, if you invest in a router, you would like to see your investment returned in, I don't know, 2, 3 years, 4 years. We need to make sure that that happens. It's not the same to be cost-oriented, like in an internet exchange or in a community network, or be profit-oriented, in which people can opportunistically deploy routers to get a profit. How that profit relates to quality of service, coverage, whatever. What happens when people charge differently for doing the same job, how to deal with clients who want to pay more because they want to have audio conference, which requires better connectivity than just downloading files. We are setting up a couple of pilots, one in South Africa, another one in Barcelona. Let's see how different cultures perceive the idea of using tokens, and how much we need to hide that to make it usable. Also, the connection between our tokens, we have a local currency nowadays, and we are discussing with some other initiatives on neighborhoods to see if these currency units can be used as a local currency beyond the network. And there are several aspects of identity, anonymity, authorization, traceability of everything. So, but it's still work underway. So that's my presentation. Thank you.
Thank you. Other questions?
Stefan Bartsmeyer. The blockchain is private in the sense that only one central entity can write in it, but can anybody read in it?
So the idea of the blockchain is because in these networks, there are different owners. So if you deal with money, you have to make sure that no one feels that someone is playing with the numbers. So inside the network, if you add a server because you want to know what's going on, you will receive a feed of what's happening in the network. So you can see everything that is going on there. You will also be running an instance of the smart contracts. So everyone has access to everything, as we used to do in the network monitoring. The economic monitoring is the same. You see everything, you contribute to the computation of values and to the consensus. I don't know if this is an answer to your question.
Anyone can read with the blockchain?
Yeah.
Okay. Then what, because it seems that most of the work is done by the Oracle, not by the blockchain itself. Once you get all the data in the blockchain, I mean, you could also as well, the Oracle could as well publish it anywhere. But I mean, I'm not sure if it is the added value of the blockchain.
Yeah, the added value is because nowadays, for instance, the mesh network publishes monitoring data among the members, and also part of it also publicly, filtering private information. But when it comes to paying for maintenance, for new nodes and everything, they use a bank account and they transfer money periodically, and it's a kind of overhead. Someone has to centrally manage the accounting. Someone has to make sure that everyone pays at the right time and everything. The idea was to automate that process and then use this ERC20 token to have a local currency and automate the operations. So the operations are done automatically without anyone intervening. And then in the end, you can see your wallet and see how much you paid, how much you got as a provider. And since we use the smart contracts, we can also write down the rules of the contract. And then, I mean, if I, for instance, connect to the network and I pay for a gigabyte, when I get that gigabyte, if the quality is above a minimum, automatically I know that my money will leave my wallet, and the provider will know for sure that since there is an instance with a deposit of money for that particular contract, that he will be paid for that effort that he does by forwarding the traffic. So it's all automating the manual process of managing money. We can discuss offline if you want.
Jonathan Hoyland, Cloudflare. Does the blockchain therefore contain information about who is sending information where? And does that therefore have privacy implications?
Yeah. Well, the network monitoring system, which is not in the blockchain, already aggregates traffic information about the traffic. We have we aggregate volumes of traffic across routers. Of course, we don't do more than that. And then for the blockchain, in the blockchain, there is information about the identifiers of the participants in the network and how much they consume, produce, and everything. And yeah, but this is kept, let's say, privately between the members of the mesh. And one of the things we are discussing is that there is a related project in the group and also with some friends that use mechanisms to increase the privacy, to make sure that the transactions are anonymous. But this is connected. It's a connection with another project. But yeah, I mean, definitely privacy is an issue, but not in this kind of networks, because internally people is completely transparent about money flows, because compensation is based on declaring how much you contributed, how much you consumed, and then balancing things. So you need to know who is it. At least you need to know the identifier of the participants.
Thank you. Interesting.
Any other questions? Okay, thank you.
Thank you very much.
I've not been able to configure out yet.
Okay.
I'm not going to try. Yeah, okay.
Yes.
Jonathan's been helping out. Thank you for that.
Hello, everyone. Shen Yan from Hobby. This is a work from Hobby, Telefonica, Carlos III University, China Telecom, and CNIC. It's named a blockchain-based testbed for the BGP verification. So it's about our research project named Decentralized Internet Infrastructure Project. Last year, my colleague Bingyang Liu has published a work named Decentralized Internet Resource Trust Infrastructure in 102, also in Montreal. And this is the update of our research. So this is an overview of our DRI system. So in the bottom is the distributed ledger layer. It is the basic of the decentralized network infrastructure, and it's in charge of provide the decentralized system structure and distributed consensus mechanism and smart contracts capabilities. So in each node, there is two key functions in the node. One is the ledger, who is responsible for the storage, and then the other part is the smart contract, who is responsible for the functions. And in the middle, we have the namespace management layer, which will storage the ownership and mapping these two features, such as we can storage the ownership of IP address, of the AS number, of the name of the macro tag, and also after the ownership has been determined, we can storage the mapping relationship between these network resources, such as if we combine the IP address with the AS number, it will produce the BGP problems. And then if we combine the IP address and with the name, it will be the DNS system architecture. And also if we combine the IP address with the identity of lightweight devices of IoT, it can describe the IoT structures. So in this work, we mainly focus on the part of the right frame, which is called BGP verification. Oh, I must clarify that here the word is there.
Yes.
Yes. Yeah. The word application layer is different from our traditional application layer. Our traditional application layer should be in the top of this system. Okay. So what we focus on to solve these three BGP issues. The first one is origin hijack. That means it is attack traffic by publishing the prefix that are not their own. So the second one is the path hijack. That means they hijack the traffic by publishing false path information. So here the example, such as the victim will receive path information from AS666, and then AS666 said that I have a route or I'm the neighbor of AS1. So the victim will forward their traffic directly to the AS666 because the new route is shorter than the traditional path 321. So this is the path hijack. And the third one is we want to solve the route leak problems. Here's a classical example here that Google was also the victim of the routing leak. So the peer-to-peer route was leaked by their customer and to the publish, and then the traffic will go wrong. So why not RPKI? RPKI is really a good method to solve a lot of security or trustworthy problems, but the RPKI is a centralized trust model. So what we want to do here is to build up a decentralized trust model, trust architecture here. So the centralized trust model, once the authority node in the high layer is misconfigured, intentionally or unintentionally, all the low layer node will not avoid the influence of their misfig. So there's some research about the real case that even though you deploy the RPKI system in the real network, we will also cause the routing or other similar problems. So this is the overview of our test bed. We use Hyperledger Fabric to build up the whole system. It is a famous consortium blockchain, and also we can implement this system by public blockchain or private blockchain. That's okay. We think that the consortium blockchain is similar with the current network structures. So on the chain, we have the consensus system, we have the chain admission system, and others are the AIS, AS1, 2, 3, 4. And in each AIS, there is at least one fabric node who maintains the IP address, AS number, ROA neighbor information, or also the transaction. And via the RPK RTR interface, the fabric node will send the ROA information through this interface and then to do the synchronization. So in each fabric node, we will store the ownership, ROA, and the neighbor information, such as here we store the IP ownership, who will own the IP prefix and the expiry date. And also there's a column I omit, should be the max length of the prefix. Another one is the AS ownership, and who is the owner of the AS number, and also the expiry time. And then there will be the ROA information. That means the mapping between the IP prefix and the AS number. And then the last one is the neighborhoods of the neighbor information of between the AS. So from the ROA, we can do the prefix origin verification. From the neighbor information, we can do the root path validation and root leak detections. So firstly, how to do the origin verification. So the IP address owner initiate an ROA, actually is IP to AS number mapping as a transaction, and then the smart contract verifies the address ownership and write the ROA into the ledger, and then the relying parties get upload ROA from the ledger and synchronize to the BGP router, and then they can verify the route. Here's an example, such as the ISB. He said, I authorize AS3, the number AS3, to originate this prefix 2001 DA8/32, and then it broadcast or multicast or multi-single cast, whatever, to all other nodes, and other nodes will receive this and verify whether B is the owner of this prefix and then write the ROA information to the local ledger. And the local ledger, the ROA will be synchronized to the relaying party and then to the router under this AS for the BGP update verification. So this is the first step. And then we can do the AS path verification. Each AS publish its neighbor information to the ledger, and the neighbor information will be used for the AS path verification in BGP announcement. And then the relying party get neighbor information from the ledger and synchronize the information to the routers. So example here, ISP-B publish its neighborhoods with ISP-A by broadcast or multicast, and then other nodes will listen this information, such as D will listen to the information and wait for the confirm. And A receive this this information and to verify whether B is his neighborhoods, and then he confirmed and broadcast to other nodes that I confirmed my neighborhoods is ISP-B. And after this, ISP-D will receive both of these two information and will verify the transaction and record the information in his local ledger. And then the relying party synchronize the neighbor relationship information to all the routers in this AS. So finally, there will be AS neighborhoods list in each fabric node stored in the ledger. This is the this used to the AS path verification, and then to how to verify the root leak protection. So each AS will register their business relationship with their neighbor into the ledger, and the business relationship will be sorry, there's a mistake. Will be certified by the payer of AS. So here, let's see the example directly. So ISP-B publish its business relationship with ISP-A as provider to customer, and other nodes such as C and D will listen to this information, and then ISP-A confirm that yes, I and ISP-B are relationship with the relationship with customer to provider. So D can verify the transaction and record this information in the ledger. That means AS1 and AS2, their business relationship is provider to customer. And then after that, all the AS will announce their business relationship and to build up such a relationship list. And the related party will synchronize the business relationship information to the router in the local area for the root leak detections. So such as the ISP-D receive a route to A is D to C to B to A. Yes, D to B to C to D to C to B to A. And the router in ISP-D can verify it by hop, such as, okay, D to C, the relationship is P to C or P to P or C to P, whatever. And since it check hop by hop, it will check B to A, maybe a peer-to-peer, maybe a peer-to-peer relationship. So they will judge, oh, this route is leaked by somebody. So it will finish the root leak protection. So this is our overview of our test bed. The main goal is to verify the DII-based BGP verification. We can get a very good, stable BGP environment on our internet. So the test bed is based on the Hyperledger fabric. Our initial participants, including China Telecom, Telefonica, and Tsinghua University, BUPT, Carlos University of Madrid, and ourselves. We will enlarge this team in the future. And stage one plan. So stage one, we will set up 2 ISPs directly connections. We will simulate multiple fabric node in each ISP area, and then to build out point-to-point verification functions. And then after that, we will enlarge our team to the cross area, such as we can build up a larger team to do the global BGP verification. This is our two-stage plan. So you're welcome to join our project. Please contact me for free. Thank you.
Thank you, Hannah. I guess there will be questions.
So would you actually put the neighbor information on the ledger? Or should you just be putting that off ledger and creating like a Merkle tree and just putting the head of the tree on the ledger? Because you don't want to populate the transaction blocks with the neighborhood information. It's going to grow. And because the neighborhood configuration changes over time. Right, that's one comment. Second comment.
Thank you.
No, this is.
Well, I know. Okay,
So,
thank you.
so the keys to sign the business relationships, AS1, AS2, is that the same keys used to sign the entries, transactions on the main ledger?
Exactly.
It has
Yeah.
to-
Yeah, exactly. So the verification, actually, to verify whether you are the legal identity, you have the legal identity to do that. Actually, yes.
So the registering on the business relationship registering could be done something like you and I sign and you countersign.
Yeah. Okay. Thank you.
Jeff Houston, could you go back a few slides to some of your primitives? So backwards, please.
Oh, which size?
Keep going. Stop. Next one.
Yeah, this one.
Okay,
Yeah.
so I want to actually clear behind those two things called IP ownership and ASN ownership. Presumably what you call an ISP1 is the holder of some public-private key pair in the blockchain.
Yeah.
Why do you own 1.1.0/24 and why can't I say I own it? How do you uniquely determine who has the authority to make that claim into the ledger, and how are conflicting claims resolved? Same thing applies to ASN ownership. The reason why these questions are critical is that every other part of what you're saying is a mix of SOBGP and SBGP and has about 20 years of history. So literally nothing about any of the rest of this is novel. It's not. It's the same old stuff we've always had. And every time we've come to this, part of the problem is the initial injection of unique authority to assert control over an ASN or IP. So I have the same question here as we've had all the time in all the other approaches. How do you determine that that asserted relationship in the ledger is real, is unique, is authentic, and how do you stop anyone else from making a conflicting claim? That's a question.
Okay. Thank you for continuously focus on our projects. So in my thought, this is some of the chicken egg problems, such as we start from where we start to our project. We start our the original information insurance in our system. So we have three potential methods to solve your question. The first one is we use an absolutely new IP assignment scheme that totally use the smart contract to assign the IP address, so we can solve the startup.
I don't see that solves it. You set up a smart contract scheme. I set up a smart contract. Set up. We're both allocating 1.1.1.1. How does this get resolved?
Oh, because the blockchain system has a consensus scheme here. They will have the order of each transactions. The first one will be accept, and later will be object.
So the first one to claim gets it.
Yes.
Wow. An interesting statement. I'm glad you made it. My eyebrows are bouncing off the ceiling. But wow.
But
My eyebrows are still bouncing off the ceiling.
have 0/0 and 0/0 over here. Sold.
And also, yeah, thank you for your support. And also, the overall system will check whether you have the legal identity or legal right to do that.
But there's no other point of authority in this framework. I mean, I don't understand that statement.
Maybe we can exchange some background of the blockchain system, that we have the relative scheme and knowledge to hold this problem, or otherwise we have maybe we have second solution for that, such as we use the current IP and DNS assignment rules, and then monitor the information from the current network, use the stability of the such as the BGP environment, and then we can construct our origin information storage. So this is maybe the second potential solutions for that. The third one is we can exchange this potential solution later. Okay, please.
So I interpret what you said is, assuming that somebody else has solved the really hard problems, which are the heart of this issue, we propose the following thing that assumes the solution anyway. And I'm struggling to understand the novelty at that particular point in time, because the really difficult issues in a distributed system and a ledger such as what we have and what you're proposing, the really fundamental issues are where you're just finessing, going, I just assume that works. And I think that's the heart of why this is so difficult to understand as being a self-contained and adequate measure that would give us the assurance we need in the numbering and routing system. So I'm left seriously doubting the viability of this until you provide those kinds of answers.
For what it's worth, we've been seeing exactly the same problem in decentralized namespace allocation and so on. And I mean, there's this large class of unsolved governance problems that are not really technical.
But I'm saying they finesse the heart of why these things are viable. Because without them, they're not viable.
Absolutely.
And with them, lots of things are possible. So rather than the upper level, it's the lower level that's the crux of these kinds of architectures and issues.
Yeah.
The crux of where the research should be, which is where I'm gently trying to.
Yeah, I absolutely agree. For whatever reason, research tends to be from the ground up rather than dealing with the governance issues from the outset.
Stefan Bortsmeyer. For the record, I agree with Jeff Houston. I mean, the biggest problem is attributing IP on the ASN to people. So everything else is just technical details. But I have one technical detail I wanted to ask about. You said on one slide that the people publish in the blockchain their neighbors. It already exists. It's called Internet Routing Registry, and we all know that it's far from perfect. So how do using a Hyperledger or any other blockchain?
Sorry, I don't catch up with one page that. Which
two
one?
slides after this one, I believe. One more. No, one. Yeah, here.
Okay.
Each AS registering their business relationship. It's already possible. It has been possible for a very long time. You publish in RPSL or anything. We observe that people don't do it properly. That's one of the biggest problems with BGP security. So they don't do it properly for many, many reasons. One of them being that business relationships are complicated. But anyway, how do you solve this problem? I mean, what makes you think that people will put in the blockchain what they don't put in today's internet routing registry?
Yes, when the player want to join in the games, they will evaluate what they will input, what will output, what benefit they can get from the system. So someone, if they do not want to input some information into the ledger, into the decentralized system, that they cannot get a benefit, that's okay, no problem. But even though you want to, once you want to input some business relationship into this system, you can get the related benefit from this system. That's your choice. That's your choice. What we do here is to try to explore a new scheme to solve the BGP related verification problems. We want to provide a new ideas, new thought, new way to comparing with the current solutions. Yes, thank you.
It doesn't strike me as really new.
So I'm kind of agreeing and disagreeing with this. I think that there's a kernel of truth here and a lot of unnecessary clutter. So the answer to the question that was asked by the person, well, the last two, the answer to that question is who is the source of authority? The last two people at the mics. The NICs are the source of authority. You cannot decentralize a registry-based system unless there's a political decision that we're going to decentralize it. And the political decision is that they want to absolutely maintain control, and that comes all the way down from ICANN and ISOC and whatever. And so what you would need to run it is that those two gentlemen would have to decide to run the chain. And once you decide that, you don't want any of the blockchain stuff. Kick it all in the garbage can. Smart contracts, they're not needed. What you want here is simply something that looks like trans, just a log. And the kernel of truth here is that we built the PKI for doing IP address allocation, based it on X509, which was the wrong technology basis. What should have happened was that the NIC should have simply provided a harvest or netter type log with a Merkle tree and just signed it every few hours and put every one of the allocations that they have made into that chain, and then anybody could pull an attestation from that single source of authority and get a proof for any allocation. And that would be a much more compact and sensible approach than the one that was foisted upon us because the NSA likes X509. So that's the kernel of truth here. But it's not decentralizing anything. It is, in fact, centralizing the existing system even more, just moving a more appropriate technology. And Bitcoin is based on that technology, but it is not that technology. And anything that involves smart contracts is not appropriate for this problem.
And may I ask what consensus algorithm have you chosen? And what kind of
Sorry, what kind of consensus algorithm?
Yeah. And
Your name, please?
Annie from Huawei. And what kind of data consistency have you achieved in your test lab?
The consensus, actually in this part, as I said, this work is only a part of our whole system. So in this case, the consensus here is not very complex. Just verify whether you have the legal identity or whether you have the right to control the prefix to publish the related information here. So what we need to do, the complex consensus algorithm may be used to other part of this system. Thank you.
I'm not going to shoot at you. I want to clarify a small point. I heard this term like a centralized name allocation. I think maybe we should discuss whether it's centralized name allocation actually is we're having a hierarchical namespace. For example, oh yeah, I forgot to say my name, Li Xiaozhang from UCLA. UCLA has all the freedom doing our own name allocation because of this hierarchical system. All the ICANN's power is and only is the TLDs. So I wouldn't call this a centralized naming system because in the lower part it's completely distributed. So I think this conceptual distinction may be important to keep in mind. And I have to say, I think Jeff is a little hard on you, but he's correct. That is, for addresses and namespaces, you cannot use this voting. This is, what you have done is you build a ledger to address the same problem that the SPGP stuff 20 years back tried. But you don't solve their problem.
Thank you, Professor.
Dino, lispers.net. So the comments Jeff were making about allocation of prefixes is because I think the way you proposed it was, I want to take this /24 prefix, and if I'm the first one in front of the line, I get it.
No, actually.
The first one who writes the blockchain. If I say I'm Dino, and my private key signs a transaction that says I want the /24, you told him that you will give him that transaction, and therefore it looks like I own the /24, but I have no right to.
No, actually. About the IP address, IP prefix and IP address allocation, the work is included in our last year's presentation. We may check it later. So we have different methods to solve this the problem. One for the build up a new system, and the other one is we can use the current scheme to keep the control of the unique.
That's fine. That was the preference. That wasn't my question.
Yes, we only express the verification function distributively and decentrally, and then we can keep the control right to the current system. We can do that.
So the point is, I agree with Philip. You don't need smart contracts because it's no different than buying something. If I'm a key holder and I have a balance and I want to debit coins or tokens, whatever, from my account to buy something, and you're the owner of something because you've been authorized to be the owner and this transaction takes place, a ledger is useful to know that Wright has allocated me a /24 and Wright has the authority to be able to do it, okay? So the fact, this is no different than a token offering. You can have a token reserve and you allocate tokens basically to owners, just like prefixes are allocated to registries. And when I want to go ahead and get a /24, I pay money to Wright and that transaction is recorded on the ledger. That's how it can work. So I think a smart contract is just complicating the situation. This is no different than like a token offering.
Hi, George Michelson from APNIC. You did present last year on a model of address distribution and hierarchy using the chain. And at the time, we critiqued fundamental behaviors of that contract. We critiqued it with things that I do not believe you can resolve. In particular, if I have an assertion in a contract on the chain that I have a prefix, a large encompassing prefix validly, and I lose my key, then you must assert the Ethereum logic of magic rights to reassert the block back into the chain, which in effect means you cannot trust the innate properties of the chain. You must bless somebody to fix the chain. Who do you bless? So this is not a problem unique to the IP address mapping in the chain. This problem exists in any fintech model using blockchains. If you wish real money to be represented in chains and you allow loss of value with loss of keys, every banking system in the world, every hyperledger in the world ultimately says, oh, it's okay, I have a magic key. You have centralized the authority of the magic reset key. You do not actually have distribution. That was the fundamental of our critique. I would also like to say, I agree with the previous speakers, public ledger, crypto-backed, unrepudiatable public ledger is fundamentally what is needed to be the visible states of a system if you want some degree of assurance of responsibility. The blockchain is not the value proposition. The public ledger is the value proposition.
Thank you.
So we're closing the line after you.
Jordi Pellicer, UPC Barcelona Tech.
Sorry.
I'd like
Sorry,
to point out that the problem of losing keys, there are mechanisms to tackle it. So it's not that you lose your private key, you lose your block of addresses. You can do a lot of stuff. You can put some special rules inside the blockchain to recover blocks. So it's not, I'd say, a yes or no question. I think it needs further debate. I know it's a problem blockchains have now, but you can tackle it. And also regarding how you assign the property, I would like to point out that if you do a public deployment, I agree that you need some registry or some public key that it has all that as a space and allocates it. But if you want to do a private deployment, you could have like a authority that has all the addresses and all the parties agree that it's the owner. Since it's a private deployment, no one cares.
We cut the line after Jordi. Can you be really quick?
Actually, on a positive note, just thinking.
That would be awesome.
So,
Yes.
on a
Thank you.
positive note, if AS1, AS2 already has a business relationship, could you use a smart contract to sublease, to lease out subnets?
Could I use?
I want to borrow a whole range of addresses from you, Mr. AS1, for 6 months. Can I just do that on a smart contract? And all of this trickles down to the
Okay. Oh, I know that.
smart contracts are not so bad.
Yeah.
Phil.
It depends on the function of the contract. Yes. So I have just one sentence to say that. Thank you for all the comments, argues, questions for the presentation. So I believe that we should open our mind, open our attitude for this new potential technology to see whether they can bring us benefit or we can bring us new potential opportunities to build up new functions and bring more benefit income for our current network. Thank you. Thank you, Doug. Yeah.
Thanks. Yes, but we should also take the critique seriously. And so we'd love it if we could actually continue this conversation on the mail list. And if your team was able to respond to the points that we heard today, that would be great.
Yeah, of course. Thank you.
Thank you. Okay, share informations. Okay, let's see how this one goes. Nope.
So I want to be quick, then I can leave enough time for you to give me your criticism. So, thanks for chairs, give me this opportunity. I'm a little scared, although I've been long time goer for IETF, but something showed up. My view tend to be outrageous. So that be gentle with me. So I think that for decentralization, it's really an important topic. That's why you block it out, trying to prevent it.
And I lost
Wow.
my mouse point.
Yeah.
My outrageous opinions here. I think decentralization needs to be from the ground up. I want to make some kind of a name for it so that I can claim I own this creation.
Give me 1 second.
I can use just the PDF, get rid of all this animation, if that's easier.
So yeah, it's first.
The point is that whether blockchain is a road towards decentralization, that's my first point I'd like to discuss with you guys. Someone said, does it go now?
Yeah.
Which way? It doesn't go.
So should take us?
I'll take this one. Okay. Multi-controllers. So people say that the blockchain is a road toward the decentralization because it has no obvious central controllers. This old cartoon, for people old enough, you saw this is so familiar. That not only the blockchain has no central controllers, it doesn't even have identities. It's just like the cartoon size on the internet. Nobody knows you're a dog or cat, for that matter. So on the software we trust. But does this blockchain thing, especially represented by the Bitcoin approach, can lead us to decentralization? My personal view is that it cannot, because this anonymity actually is a killer. The only way you can gate the system is by this show your muscle, proof of work. Who can do the most amount of proof of work? Whoever has the most resources. There's lots of academic publications that did the measurement and shown that where are the major players, the big players on the Bitcoin. I think the number is something like 75% or so, all located in China, because there are people who gaming this technology. This is before the Chinese government did something against it, gaming the technology to make the profit. So therefore, this proof of work, of proof of X, can be stake, can be storage, can be anything. But as long as you want to say proof of resources, this is really making the rich get richer. Because the more resources you have, the more power you have in the system, even though you are anonymous, so-called anonymous. But there's different approaches to this broadly defined blockchain interaction. That's a distributed ledger. I think someone mentioned that. So that can be represented by this specific example called a hyperledger. I give you the pointer there. How is hyperledger different from proof of work blockchain? First of all, you can see that hyperledger is doing something important, relevant, like a case study on the change of healthcare stuff. I think that later there's this financial discussions or something that believe that's, I haven't heard that yet, but my gut is that goes on the same direction. What is that same direction? Here's the statement. It says that where hyperledger fabric breaks from some other blockchain systems is that it is private and permissioned. Rather than open permissionless system that allow unknown entities to participate in the network, therefore you require protocols like proof of work to validate the transactions. It's not so much validate, it's really gating the transactions to say whoever have power, you can prove your stuff. Whoever not, poor, you cannot. So the memberships in the hyperledger fabric, through a trusted membership service provider. Now you may ask a question, wouldn't this MSP become the new central controller? I must admit that I only learned about hyperledger like 3 weeks ago. And I've been mostly on the road, so I haven't dived into the literature to see exactly how it works. But I kind of got a rough idea. I cannot give you specifics of hyperledger. I want to show you by another example, which is, I think we developed something along the same direction like a hyperledger, but before we knew it. So call me ignorant. There's so much stuff going on under the sun. Sometimes I feel I'm justified not knowing everything, but I'm trying to catch up. This other example, actually, is something we've been working on for the last couple of years. There's a very drafty draft hanging on the archive. Don't kill me if that said something wrong, because that is still just a work in progress. But I want to show you the logistic of the basic idea. So it's a D-ledger. It's really kind of a tool. It's really distributed ledger that facilitate the security solution development. By itself, it's not security. It doesn't guarantee provide security per se, but it's a very effective and powerful tool. So essentially, it's an immutable distributed ledger that requires all the entities in the system log everything they do into the ledger. And through some clever recording entry scheme we call the interlock. It makes the whole system to be totally immutable. No single party, including that this identity management provider can make changes to the system without being publicly locked into the system. So just like all the other members, the identity manager in the D-Ledger artisan must append all its actions, proof of new members, issuing of a certificate, revocation of certificate, everything, you log into this immutable ledger. Mistakes, correct actions, everything, crashes, failures. So what good does this do? This is actually based on some very old idea we had. It published, you can see that more than decades ago, in that short paper called Security Through Publicity. Again, don't kill me if that paper said something wrong, because you have to forgive us for mistakes because that's old. But nevertheless, I think it gets some basic ideas right. It says that the key principle behind this design we call the PSKI. I don't even remember what PSKI stands for. PS is definitely public space, maybe knowledge infrastructure, because this statement states that every action should be made in a public space. This public space concept, we borrowed from others, derives from similar principles to those in other areas of public knowledge. Acting in public does not guarantee that the actions is correct, but it does provide users with a quantifiable set of information, what has happened, who has done what. The information and semantics that enables applications to construct their meaningful actions, decisions, based on those, whatever things happened. I think that this really echoes back for some comment I heard earlier that the one most useful tools is this distributed ledger, immutable, distributed, available everywhere. And this tool will help us build the future secure systems. I would also mention that this identity management is important. You cannot just, push off that idea to say whoever grabbed the identity first will be the ownership. That's not the solution to the problem. The so-called DNS as a centralized name allocation system, I think, as my personal opinion, it's an incorrect statement. I think the unique namespace is critical for a healthy internet. And that's what the ICANN's TLD allocation is about. It's not centralized name allocation system, because beyond the TLD, every single party has their freedom to do their own name allocation. This hierarchy is needed just to assure the namespace uniqueness. And also I'll make another point, that is the namespace identity is and should be decoupled from your trust relations. It doesn't mean that there's a DNS name, it's a trustworthy party. And that must be separated out. You can share with someone under the same hierarchy. It doesn't necessarily mean you trust it. How many names under the .com now? I think 3 years back, I asked someone that they said that there's like 300 million, and I don't know what's the number now. How can you trust anyone under the same domain as the trustworthy or not? But I definitely give you the unique identity. There's one person, one entity that owns that name. So now I want to run animation to disclose one line at a time. What I really mean by ground up, it's really need to be from ground up. Look at today's distributed ledger systems. They are built on top of existing TCP/IP protocol stack. And we all know that IAB has published this internet draft on the considerations on internet consolidation, as mostly talk about the consolidations of power as a sit on top about the services, the applications. And my conjecture, that's why I say I'm making outrageous opinions. My conjecture is that the consolidation of the top inevitably leads to the consolidation of the supporting substrates beneath those. That's inevitable because of nature. It's a market economical drive. It's only when the underlying substrate get more kind of consistent with the upper, there's more profit to be made. If you want me to give you proofs, evidences, I will come back with a well-prepared talk next time. So therefore, if you really want to build this distributed ledger as a useful tool towards decentralization, you need to build this ledger on top of a decentralized system, decentralized network protocol. And then here I give you this one example. So our D ledger is built to run on top of named data networking. I bet not many people have heard this buzzword NDN. So here's a pointer. You can take a look. This project has been going on officially since 2010. But Van Jacobson, a familiar name to many of you, he gave the first talk in this direction in 2006. Again, the concept has been there for a long time. What have we done over all of those years other than burn your taxpayer dollars? We have matured the concept. We have to build a prototype running system. And I think we now know how to roll it out now. And last, as an invitation, so we run this annual NDN community meeting. And then thanks to NIST, they will be hosting this year's meeting not too far from now in Washington, D.C. So whoever interested, take a look. I have a deck of flyers on the IETF registration desk. Thank you very much.
Thank you. We have time for one question.
Well, a bit more of a comment. Thinking through the previous session and then this one, I'm thinking that ledger technology is not really very good for decentralizing control. But there's another type of security, and that's accountability. It is extremely effective at decentralizing accountability, because if you have an authority that you give a task and they put the information into the log, then everybody can audit them, which is, of course, the heart of trans. So if we stop thinking about security purely in terms of access control and instead broaden our view to accountability, a lot of this makes a lot more sense. But I don't see a lot of this.
That's what it says. You need that ledger to show you have to be accountable, because everything you do will be in public and you can no longer change it.
Just to, again, thinking about this talk and the previous talk together, sorry, Jonathan William Cloud there, wouldn't the sort of blockchain / canonical way of doing this be, if I want, you know, /0 of, or like, if I want the entire internet, then I just have to get more than half the people to agree with me. And so you can have it, you don't have to bless anyone per se, you can just say, as long as half the people agree that I own this address, I own it.
Can I answer that one with respect to what Leisha just said very shortly?
Yep.
No, because we have two models, proof of waste or work and identity. What Leisha was just talking about was identity in order to get into the ledger. What you're saying is if you need over half of something, that would be proof of waste. There are very different ways of using the same structure.
Right, but isn't the idea that you do, like the whole, you have to just pick one
Yes, exactly right. And what she's saying from the ground up, she is picking identity to enter, which is completely different than proof of waste. Yeah. Sorry. I would love to see research that shows that you can use them together effectively without one totally overtaking the other. I've not seen any.
Okay, thank you.
Thank you for being gentle with me. But I welcome criticisms afterward. Shoot me my emails.
Okay, great. So this brings us to the end of the Dinrg part of this session. And so we're now handing over to...
We had talked about, we'd like to talk at some point
Oh,
about an
sorry.
interim.
Yeah.
But we can take that to the mailing list.
Yeah.
In the interest of giving Shigeya his time.
So Shigeya, where are you? And where are our blue sheets?
One.
Okay.
Where to plan?
No, here, this one. This one? Okay.
Hi. Thank you very much for coming, and thank you very much for allow me to have this time meeting. So, this is
Now, so as you see, the G20 community mentioned about it. I'm going to show you what happened in the G20 Fukuoka anyway. So let me describe what happened in the G20 Fukuoka. So let me first describe what G20 is. So G7 is Canada, France, Germany, Italy, Japan, UK, and US. And G20 is 20 countries, including a G7. So the G20 finance ministers and the central bank governors meeting, which held in Fukuoka this year, means that the financial minister and the central bank governors of each of these G20 countries, plus IMF and the World Bank, etc. That is the G20 Fukuoka meeting consists of. So prior to the meeting, this was happened, initiated by request from Japanese government that FSB, Financial Stability Board, you might heard of it from the news, have published a report on July 6, 2019, that is just before the G20 Fukuoka meeting. The document is initiated from the request from the Japanese people, and what the document says is it is important to have a dialogue between the financial regulators and tech communities, stakeholders, including the tech communities. So this exact statement appears in the report, and it appeared just before the G20 Fukuoka meeting. So we were working on to have a workshop called a high-level seminar on financial innovation during the Fukuoka meeting. At the meeting, the attendees of the G20 meeting come to this session and listen to this panel, these panels discusses. So the picture is really small, so I'm not sure whether you can see or not, but this session is moderated by Professor Jun Murai of World Project, Keio University, and also with Professor Matsuo from Georgetown University on the board, on the panelist. And also, I want to mention that Dr. Adam Back, who is a very famous cypherpunk, is also on the board, on the meeting to talk on these specific topics. So the financial governors of the other guys listened to the fact these guys talked. So this meeting itself is a multi-stakeholder simulation or talk among the stakeholders. So finally, each of these meetings is published a communique. And in this communique, we can see the 13th paragraph that the mentioning that we welcome the FSBs directly or whatever. So it is referenced to the document FSB just published and saying it is important. And I think this is the way the communique wrote, but we welcome means that we are really listening to. So they understand that this topic is very important. And I want to mention that if you click the link to the call for participation of this meeting, that at the meeting there are several opening remarks, and one of the remarks is spoken by Toshide Endo, that is the commissioner of the JFSA, and he mentioned about the IETF. That is unusual, but they understand that IETF is important role in the internet deployment and internet technology development. So they think that it is important to have similar people working together with them to make possibly the standardization, I don't know, but to have a better multi-stakeholder discussion forums. So tech committee draws is that now regulators in the G20 countries share the idea that it is crucial to have such a dialogue among the stakeholders, including tech communities. So, and also, for the regulator's point of view, the most critical critical issues are consumer protection and the prevention of the use of technology for criminal activities, including money laundering. But also, they understand that the blocking innovation is a bad idea. Blocking innovation by regulation is a bad idea in this context. So they want to promote, but at least they want to prevent these two issues. They want to discuss with these two issues in the mind. So I'm going to do the Q&A, but from first, let me quickly review some of the comment I got from the by email. So several people mentioned in the DNRG mailing list, the internet has a crucial role to establish DLT-based technology. That is given, right? So of course it is, right? And the DLT relying on some of the IETF documents, of course. And I know there are tons of problems related to the use of the bad ciphers, which is not well understood. And there are guys who is creating new ciphers. But as we know that we are very carefully pick ciphers to be deployed and controlling that from the IETF document. So that's a good idea. So they are relying on such kind of document. I want to also mention about some of the discussion by Nakajima-san over there on general security consideration for the crypto asset custodians. That kind of the document might be useful, but I personally think this document fits to the IETF community or not. I'm wondering whether it is okay or not. So we need to find out the right venue to discuss this sort of document. Of course, clearly cipher is the IETF's work, of course, and possibly other document might be under the control of the IETF, but I'm not sure on the lower part of this slide. But it is clear that this kind of document is important to share among communities. So interoperability, needless to say, we understand the importance of interoperability. So everybody talk about interoperability is important. Some of the people want to discuss about the interoperability with the blockchain technologies. And that's true, but I think it is too early to think about standardization of DLT or interoperability of DLT. So I honestly think it is too early, and we can do that in the future. But at this moment it is too early. So I'm not into this yet. Still, we need to find out a good architecture of DLT. I don't know, but we need it before we start working on the standardization. And of course, there's no de facto standards yet. So finance, we do care about finance a lot. So DLT relationship to finance in terms of technology is important since DLT depends on the internet as we discussed. But any application depends on internet, right? So why fintech not? And possibly in the certain context, it might be more important. I may skip some of the slides, but anyway, so some of the discussion in my mind is that somebody mentioned about whether we can discuss ISO or ITUT or IETF or W3C. I have no idea. Of course, these communities, each of these communities has own goal and a different stake. So it is not simple to answer, but like the document I mentioned and created by Nakajima-kun is that it doesn't fit any of them, right? But important. So we may need to have a new place, or we can try to fit in some of the communities. I don't know, but at least we need to find out what kind of document we need to be standardized, and where to do that activities. Somebody mentioned about EIP, Ethereum, the improvement proposal thing, where Bitcoin itself has a BIP, and each of the software development community has their own way to control such kind of standardization. But we possibly need something, but I'm not sure. And we need to discuss, and we want to listen, to have a community, because regulators or G20 regulators want to talk to somebody in a tech community who want to talk to such kind of people is a question. And we need to find out a way to do that. And this potentially affects some of the work we are doing here, I think. Many people may not think this is not IETF's work. We do not have relationship with this work. I think that might be true, but it has a potential that we need to be influenced by these kind of activities. So starting earlier, so I asked to have this meeting to start dialogue with people in IETF community. So this is my introductory part. So please provide a question or comments if you have. Silence.
Hello, Christine Roniger from the Internet Society, but speaking in my personal capacity, it's just a clarifying question. What I didn't understand fully is, I heard from you that the G20 finance people are interested in speaking to tech community, particularly the standards community, but what's not clear to me is what kind of conversation do they want to have? What are they interested in understanding? What help do they need? Perhaps if you could clarify that a bit more for me, that'd be helpful. Thanks.
One of the things, this is very, very specific, I think, but they want to find out how they can prevent money laundering. And that is very related to the how the identity is managed. Of course, since if you want to prevent that, you need to do a KYC to bound a real physical person towards some identity in the cyberspace, whatever. So there's a ton of discussion we need to do, but that is one of the examples they are really interested in, to talk with people, to solve the issues without preventing the innovations.
No, so I think there is a role for the IETF, as I said very shortly on the mailing list. So both the G20 people and the FATF, this is if you know who they are, the number one concern is anti-money, AML, KYC, and anti-terrorist financing, whatever the phrase is. And so IETF has a whole tool set of stuff we've developed for the past 30-something years. X509 certs, Phil. We could use it for that. I was looking at just briefly just now, the crypto assets draft terminology, which is very good. First suggestion would be to align it with the terminology of the FATF. They call, custodian providers as VASPs, virtual asset service providers, and they have a model there already. So it'd be good if you could update that document. And also the crypto custodian people, they should look at, NIST has got a key management lifecycle, because the custodian, this is a centralized custodian. This is the other thing. You have to say, when you say custodian companies, you have to say centralized or decentralized. So in this paper, it's a centralized, in your draft, it's a centralized custodian. There's a whole slew of stuff you could use to protect the keys of your customers, right? And also there's a blend in the sense that when I open an account with a custodian, I may not be given a key pair, that all the trading is done using the one or two keys belonging to the custodian. But I think this is, back to the original comment, I think this might be the group in the IETF to start talking about this, because there's definitely a lack of understanding, like the FATF people didn't even know, and I'm talking about the Treasury Department folks, they were not even sort of sufficiently aware of the existence of X509 when the technology is used big time in our US national security infrastructure. But, I think it's good.
Thank you very much for comment.
Rich Sauls Akamai, congratulations. This is like free of hype and realistic, and wherever and however it ends up, I know people at my company are going to follow along and want to contribute, because we've done some prototype experiments with Mitsubishi Bank. Mitsubishi. So thank you for a breath of clean, accurate, fresh air.
Thank you.
Hi, Philhan Baker here. I come not to praise Bitcoin, I come to bury it. I really liked Paul's comment, proof of waste. Is that yours? Oh, okay, sorry. Because I'm going to be using that. If the G20 folk want help on working out how to unpick the Ponzi schemes and the fraud or whatever, I've been thinking about that a lot. There are many points of vulnerability in that ecosystem, and that ecosystem is pure fraud almost. However, what really has been concerning me is that at heart, they have hijacked a really cool technology, the Harvester hash chain, that was invented it was patented in 1990.
Yeah.
And that is something that can be and should be applied. I would like to see infrastructure that allows that to be applied to projects that isn't contaminated by all the fraud and all the waste. I've been doing some work in that vein because I need some facilities like that on the mesh, but I think that we need to detach. And Libra might well be part of that detachment, because had Bitcoin collapsed 6 months ago, people might well have said, well, that's because the crypto was wrong and it was, Now, if it collapsed tomorrow, then people will be saying, well, of course it collapsed because the capitalists came in and just, and took it over, which, whether it's true or not, is a completely different story and wouldn't bring the rest of crypto down with it.
Thank you.
So Paul Hoffman, I'm going back to your previous slide about where to take this. Because I think that was your big question. Your list is very short there at the top. And I propose, given what you said earlier and also the answer to the first question from ISOC, I think really where you want to go is to places that specialize in identity. And, Thomas correctly pointed out that we do some identity here, or we did it 20 years ago and sort of finished it. But that's just format. That's not describing identity. That doesn't say how you tell that this person is not this person, or that this private key is not associated with this person. There are plenty of really good, mature identity communities out there. Some of whom are financial related, many of them who are not, but wouldn't mind being, I would imagine. And I think those would be the best communities for you to start with. The technologies are well known. You know, as Phil just said, we're actually working on something that is post-patent. You know, it's that old. It's not, you don't have a technology problem. You have an identification problem. And there are plenty of groups out there that really are trying hard to deal with individual identities. Different groups are trying to deal with corporate identities. That is this company the same as that company? Is somebody who says that they work for this company actually working for that company? We're dealing with that in the United States, at least right now, with what does the word Huawei mean? You know, things like that. So I would say go to those folks and start to get that and assume that the technology will follow. If you're finding technology gaps at that point, sure, come back. I don't think the W3C would be an appropriate place on that list. ITUT takes their time on things, but actually have a fairly wide range of things. IETF are good for point solutions, but I don't hear that that's what you're asking for. So look at the identity space there, and there are plenty of people here who are active in the identity space. So good luck.
Yeah, thank you very much. Yeah, actually, the list and the other things are really undercooked, but so it's bringing here this slide is too early. But I think it's a suggestion that identity community is a great idea. We want to think about that yet. Of course, that was listed, but that seems to be very important to start with that. So thank you very much for the comment.
You know, listeners on that. I don't know if you just want the standardization effort to be focused solely on fintech, but if you consider Leisha's ground-up approach, I think you should consider it so we have a holistic design from the network layer all the way up to the application. I don't know if that's boiling the ocean, but at least it's a good place to start before the organizations get together, thinking at those levels.
Yeah. As a researcher, I really like the idea. Yeah. And of course, I will spend some time on the looking at that, of course. Thank you very much for comment. Okay. It's 15 minutes more, but any other comments? Okay. So if you have interest, please, I will try to, I'm not sure whether I'm going whether I'm posting some information on the DNRG mailing list is not good or not. So I probably need to create a list of people who has interest anyway. So if you have interest, please kindly let me know. I have you might know my email address. I have posted a message on the DNRG mailing list, so you are sure that my email address is there. So please contact me if you have interested on this.
Hirotaka Nakajima, Mercury, and also K University. I actually the author of the security consideration for crypto asset, and I had a presentation in the previous IETF and the SEC dispatch working group, and the recommendation, the comment from that talk, that is like we may create the mailing list to talk about this kind of issue, and see if like how many people interested in and whether this is a part of the IETF work or not. So yeah, and the Shigeya-san already mentioned that it's a good idea to make a mailing list to discuss like whether this is IETF work, but or they have like how many people interested in those kind of issues. Yeah, thank you.
Thank you.
Melinda, short and fastly, seems like the sort of mailing list discussion is highly decentralized and a little chaotic as well. There's been a lot of interest in the possibility of doing something at the IETF related to decentralization, something standards related. And so we can certainly kick off a discussion about that, and with the possibility of having a side meeting on the technology itself, or even possibly a BOP in Singapore or in March in Vancouver. So let's use the Dinrg mailing list. keep the Dinrg mailing list informed, and we'll see about setting up a non-working group mailing list at the IETF or in some other venue.
Thank you.
Seth Gentle, I, on the weekend, was at DWeb, which is the distributed web summit. So there's 400 and something folks. Tim Berners-Lee was there with people talking about some of these issues. The community is still very new. This is the second year that they've run it. But there were folks from the Scuttlebutt, DAT, IPFS, a bunch of blockchain communities there, as well as a whole bunch of other people interested in this sort of thing. So if you're looking for more people who might be interested in standardization work, then that's another place that you could go and talk to.
Thank you. Okay. Good to close the meeting. Okay, thank you very much.